All right. Well, how's it going, everybody? So tonight we are starting a new project. I'm not. I haven't really planned much of this out. It's just something, and it's not even like something very unique. But it's just something that I wanted to know how to do. So I've ordered. So I know. How's it going, Atikta? I know the last project we were still working on the NeoPixel sign and everything. I've ordered the parts for that, but it is going to take them some time to get here. It takes time to make circuit boards and all that stuff. So that is on its way. So I'm going to start another project in the meantime. I think from the last project, one of the things I learned is that enclosures are more expensive than I thought if you have them custom made. I either have to get my own 3D printer that is capable of doing that kind of stuff, which would be kind of expensive, or I have to do something that doesn't rely on that. So this next project is going to be purely electronics. Just so I just realized my camera is like really high up. Hang on, let's try that. So this next project is going to be purely electronics, just because I know that stuff is cheap and easy to get, and so I think that will help me figure out exactly, or help me complete something without running out of money or something like that to do it. So that's the plan. So what I'm going to make is a programmable power supply. Um, why I want to do this? So you can buy power supplies and AC/DC converters. They're all around you. Typically like phone chargers and things like that, or the power supply in your computer, or anything that runs off of low voltage current, like basically every electronic, except for uh, higher powered stuff, things like appliances like washers, dryers, vacuums, toasters, all that stuff was running off high voltage AC, but most things like electronics are running off of low voltage DC, direct current. So what we have to do, because all of our power comes in through alternating current lines, through AC high voltage lines, is we have to convert that to DC. So your phone charger, that little brick that you plug into the wall, that's exactly what that's doing, as well as anything else that does a conversion. So I want to make one because I want to know how to do it. And I figured, since I'm going to go through the trouble, I know that the DC side of it I'm better at and is a little easier. So I'm going to upgrade that a bit. So I'm going to make it adjustable and programmable. Adjustable meaning I can adjust the voltage level, anything from like 1.8 volts to 24 volts. Hopefully I can find something that can do that. Maybe, maybe not. And then I need to make it programmable in that I want it to be able to be controlled from a computer. So you can plug it in through a USB into your computer, and using a little interface, control what the voltage output is. So I know those things sound complicated. I don't think either of them, thinking through it, seems like it wouldn't be too hard if you get the right parts and put the right circuit together. But obviously I don't know what hurdles I'm going to face along the way, or what the limitations of the parts I can buy are. So yeah, let's get started. First things first, new project. We got to come up with a set of requirements. I think those Dogecoin bounties are probably out of date because they're for the last project, but I'm just going to roll with them because I don't know what I'm going to need for this yet. All right. Also, I've repositioned the mic into a different spot. I didn't like how things were sounding. By the way, total aside, I set up all of those streams that I have been behind on to upload to YouTube. They're all uploaded. They're going to come out one every day at noon for the next until like October 6th because I'm so far behind. So those archive streams will be going up. In the process of doing that, I had a chance to go through my audio again and realized I didn't really like how things were sounding just because of how close the mic was and everything. So I moved it back a little bit. Hopefully y'all can still hear me just fine. It looks like my audio levels are still pretty high, so I imagine you can. But yeah, I wanted to reposition things. So if it sounds weird or different or whatever, or you think it should sound better, let me know. But that's why it's different. Okay, so I think our requirements, I'm not going to spend too much time on this. I'm going to be pretty flexible. I just wanted to get some basic stuff down. Uh, Needs to convert 115 volt, 60 hertz AC to DC. Obviously, if you couldn't tell from my accent and everything, and when I stream, this should tell you that I'm in the United States. Actually, I don't know. I think there's Maybe parts of Japan have this. I don't know if Canada or Mexico does. Definitely not Europe, but the 60 hertz thing is weird too. Kind of specific to the US, but I don't know. I think actually Japan's power grid is like split, like half of it's 60 hertz and half of it's 50 hertz. And I can imagine that's a nightmare to deal with. But okay. Anyways, so we need to do that. And actually, let's just go ahead and number these. Oh, also, if you get a chance, tell me how your Tuesday's been. I think I want to be able to do multiple voltage outputs at the same time. I'm going to shoot for 4. I don't know that I'm going to actually do that many, but I'm going to put that many down. Four different DC voltages simultaneously. I think each one should be able to put out an amp of current. You've applied to 16 different jobs over the past week and a half. Wow. I hope you hear something back. That's epic. Sounds like you've been very busy. Well, good luck, dude. I hope that works out for you. Please let me know how it goes. I'm excited to hear how that's awesome. Maybe not like an amp of current out of each one, but overall it needs to supply an amp. I know like you can buy things that do this, like desktop, programmable power supplies, big box with a fan in it and everything to cool it, plugs in through USB, and it'll put out like 3 amps at any voltage between 0 and 30. I don't know if I'm going to be... obviously, I'm not going to make anything close to that good. I just want to make something that kind of works just to know how, but I don't think I need to do 3 amps. We'll shoot for 1 amp, see what happens. DC output. I was originally going to try and do 30 volts. I think I'm going to just go for 24. Volts. I'm thinking we put basic LEDs on it to indicate which ones are on, like which outputs are on. And probably honestly, I know this is getting into some complexity. I think it needs a display or something to say what each voltage is at. Because it causes less confusion. Anything else? Maybe each output should have its own mechanical switch, just in case. Maybe it needs to have protection. Can you set it up for selectable voltage? That's what I'm going to try and do. That's why I want this range, this DC output 0 to 24. I want to be able to select what voltage I'm putting out of each individual channel. It's not that hard to get an adjustable voltage regulator. It's more of an issue of can we supply the current required and how much, like, if you want to supply 24 volts, then you typically have to have something coming in that's higher. So I don't know if we're going to be able to do that. We'll see. But yeah, that's the whole plan. It's going to be selectable. So I'm going to put these as question marks: overcurrent protection and mechanical switches. Okay. I think that's pretty much it. We need to start block diagramming to see where we're at. Some of this is still pulled up. Let's see here. Okay. So I think, sorry, dial instead of switches. No. Well, what would a dial would be to like adjust the voltage, right? And I'm not really like, we could do mechanically adjustable, but there is a certain amount that does increase the complexity a bit, because I also want to make it controllable from a computer. And what happens if the computer changes the voltage? Well, then the dial has to move as well somehow. And I don't think I can do that. At least not easily. So I'm thinking leave the dial off. The switches are literally just to turn the ports on and off. Like you'll turn it on the computer, but there's still a mechanical like hard cut to turn it off if you're like having an issue or something goes wrong. You know. I like the idea of a dial, and a lot of power supplies already have that because it's a great way to do it mechanically. But I'm gonna try and do it all through software. All right, so basically this whole thing is going to be on a circuit board. We're not really doing any custom enclosure, which is probably not a good idea on my part. It probably needs an enclosure of some sort since it's high voltage coming in. Oh, good call. I forgot to turn it on. How about now? Those of you on YouTube probably can't hear the music because I don't have it selected to record there. Sweet. Good to know that's working. Thank you for checking on that. I'd have just gone the whole stream without realizing it. Okay. I also desperately need music recommendations for royalty-free stuff. I gotta sit down and just find some more music. All right. So what's next? Okay, so we got to figure out exactly what we need. So the way this is going to work is it needs some sort of micro to control it, run firmware, and handle all the turning things on and off, and controlling the voltages. Um, and then we need power coming in through, obviously, the shoot. From the wall. Sorry, I just totally had a moment there. Um, Power coming from the wall. And so we're effectively going to have two different power supplies, right? Like one from the USB port, one from the wall. I think the one from the USB port controls the micro, the switches, and everything that adjusts the power and turns it on and off. And then the wall is obviously supplying the actual current that's going to come out through that. So the way we designed this is going to be a little weird because we're effectively going to have two different power supplies coming in and controlling one board. I don't know exactly what that looks like or the right way to do it to protect things. See, I'm thinking from a standpoint of when you connect the grounds together, right? Like all the grounds should be the same. But I don't know if you could just plug the ground in from the USB port into like the ground generated from the wall outlet. I don't know if there's a chance that that will just like go away wrong and burn out a port or something. Yeah, there's a lot that could definitely go wrong with this. I'm gonna try not to burn anything down while I'm doing this project. This should be goal number one. All right, so then thinking through that, so we need AC DC input, or AC input. And then let's make this red. So then we need, here, let's make this yellow, a transformer, because we got to bring the voltage down. So wall outlet, right, is from, is at 115 volts. We need to bring it down to like 24. So we need a transformer to do that. One thing to note, I don't think this plays in here. That 115 volts, I believe, is a root mean squared measurement, meaning it's a certain, I don't know exactly how the calculation goes, but basically it's a measurement of the peak and the oscillation, what the produced voltage is. The actual like peak, you hear that it's 120 volts or 115 volt coming out of your outlet. It's actually probably closer to 170 at its peak, but because of the oscillation, it's measured a little lower. So I should look into exactly how that works again. All right, so we need a transformer. Actually, you know what? I'm just going to slide this over. And then we need another one of these. Drop that right there. This is the conversion part. A full wave rectifier. It's a fancy sci-fi sounding term for a network of diodes that changes this to DC current. When we get into it, I'll explain kind of how it works, because I'll have to learn again how exactly it works. Yeah, that's just a circuit component. Let's leave that. Okay. And then we need a capacitor. It's just really big capacitor. For reasons. Whoops. That's another circuit component. All right. Next, we need probably, let's see here. Let's do 4 times. I'm trying to decide. Should I just do the linear power supplies or linear voltage regulators like I have been, or should I do something switching? Because if it's linear, it could possibly get really hot, and I am semi-worried about that. But linears are a little more robust and easier to work with. I don't know. We'll look into switching. Just because, but I might switch that back to linear if it becomes expensive or hard to work with. Trying to keep our component counts down. All right, then I'm going to do everything on this side of the circuit in blue. Switching regulators. Then we probably need 4... so I'm going to use solid state relays this time to turn the power on and off. Or maybe I just say relays. It might be kind of fun to hear it click. A big mechanical relay on it. All right, and then so 4 relays. We need... Okay, yeah. Let's see, we need voltage control, circuitry. I imagine these are just going to be like digitally controlled potentiometers, because I think that's how you do that with these adjustable power supplies. Is it's just a changing resistor divider, voltage divider. We need a micro. We need a brain. So in the past, we've always been using teensies for this as well. I'm going to see if we can find something else too. There's a lot of this project too that's going to be trying out new technologies just because I want to learn how to use them. A cheaper solution there would be great because that's one of our biggest cost things when we're ordering components. And so it'd be nice to have something cheaper. Plus, frankly, I mean, like, Arduino is great, but I would love to have just a normal IDE with like debugging capabilities. All right, and then we need status LEDs. And then like a display, right? We need our voltage displays. All right, did I hit all my requirements? I'll put 1 amp for each. That's looking me insane. LEDs, overcurrent protection, and mechanical switches. I forgot about those. So maybe this comes down here. Times fuses. And then I'm probably also going to use the AC/DC in the micro to measure the outputs and everything before firing up like the relays and stuff. And then probably, let's see. Let's go right here. 4 times mechanical switch. Probably just a single pull, single throw. Okay. All right, I think that's everything. Um, all right, so now how all this stuff connects together. I guess that's the part we got to do. So that goes to the transformer, which goes to the full wave rectifier, which goes to the really big capacitor, which goes to the switching regulators. You know what else goes to the switching regulators? Voltage controller. I don't know if I'm going to be able to... There might be an enable thing that allows me to turn these on and off. So I might make use of that. Oh, I forgot about the USB port. Probably go for a USB-C if we can. Why not? That should be a two-way probably. All right, I'm probably going to have the mechanical switches and the micro both control the LEDs. Oh, and then we need the output pins. Whoops. I'll probably put a bunch of different things there for the outputs, just to have a bunch of options. Okay. Can you power everything from the DC supply and isolate the signals from the USB? Probably, almost definitely. I was trying to figure that out. Like, what's the best option there? I would need another regulator. So it'd be adding a part. Whereas if I just power through the USB, I don't have to worry about that. I just assume it's 5 volts. Though I guess I would probably need it anyway because the micro probably runs at 3.3. I don't know. What are the merits of that? Like, because I think that's the most confusing part of this right now is how this is all getting connected, like how the two power supplies are interacting. See, this is a mark for the teensy stuff. If I just do the USB straight to the teensy and forget that port, I can use the teensy power supply to run all of this, and it would have it has its own internal regulator for that. Or it could isolate too if I wanted to do that. All right, we'll think on that. We'll leave that one open. Thanks for that thought, though, Terrence. That's a really good thought. Because that would especially go a long way towards isolating the USB port from any mistakes I make. All right. Well, we got a pretty good idea of what we're doing there. So now I guess we need to attempt to make it. I'm just going to barrel through this at like lightning speed. Normally I'd go through and try and find parts first, just to get an idea of what exactly I'm doing, but it's pretty easy to change things, so I think we need to take advantage of that and just get more into the weeds, because oftentimes we spend time finding parts and then find out later we need to change design or something. Better just to design like a basic version of it. All right. Let's make sure this is all saved to the server. Cool. Okay, first things first though, I will need to find the correct inputs, correct parts. Let's see what AC input gets us. AC-DC converters. Let me just go ahead and take a look real quick at how easy this would be if I just like bought a part, and then I'll continue on this whole doing it myself thing. What is this? These like super basic converters that do exactly the thing. (200 milliamp, 85 to 305 volt AC to 70 to 430 volt DC. Oh, that's the input, and then output is 5 volts. All right, so it looks like somebody has something put together and you could do it for $1.50. So I'm going to show you how to do it for a lot more money and time. All right, what am I looking for? I may not have like worded this right, but I want just, I don't think this is it. Yeah. I just want like a plug, right? A place for something to plug into. Lancasters. What is the name for them? I remember seeing something like this before. I just don't remember the name for it. Oh, shoot. AC outlet, maybe. Power entry connectors. Right. Those are all DIN rail things. All right, here we go. In stock, active. 3,700. Wish I could go like check out DigiKey's warehouse one day. That'd be awesome just to see like how big the building is to hold all of the random components and stuff that they do. Mounting type. Is PCB an option? Surface mount. Do they offer through hole? Is that an option? It's not. Okay. So this may not be totally possible, really. Yeah, not exactly what you're looking for here. I guess that makes sense. I think typically the stuff isn't on the circuit board. It's like held, yeah. I suppose I could just use a terminal block. I was just hoping to be able to get like that standardized plug that, you know, all PCs use and everything. That'd have been nice. Does anyone know what that's called? Power entry connector is the same word that they're using. What's this? Oh, just like extra pieces. Hold on. There's gotta be something here. Receptacle, male blades. Alright, so we're getting there. Obviously, this doesn't, you know. Gosh, I could see this going really wrong. Shocking the heck out of myself if I use one of these. Obviously, if I wire it up correct, that should never happen, but these are all just panel mount kind of things, right? For good reason. What's this? Snap in through hole, right angle. A, closer? I think that's the closest to what I've wanted, but I don't know. I feel like I'm gonna rip this right off the USB because it's a. You all know how much force it takes to unplug something. Like, it's a lot. Something like this makes a little more sense. All right, let me look at this. Oh, this does have the tabs going down, so you can solder. It just also has them sticking out. That's kind of scary. Hold on 2 seconds. I have a thought. Can you buy like covers for a PCB? Like something that just goes over a select amount of components or something? I know you can get RF shields. Because something to like cover all of the AC stuff would be awesome. Just to make sure I don't do something dumb. I think this is just pre-made enclosure boxes. Honestly, this might be the right route too. Just cut some holes. What they got in the RF shields category? Lots of fun stuff. See, this is something that, kind of what I was thinking of. How about let's just look up shield. Oh. Nothing yet. All right, well, I can tell already that I'm going to go way down a ton of rabbit holes here to try and figure out everything I need to do. That's fine, though. It'll be a fun learning experience. So thank you all for bearing with me, and let's just see everything we can learn about. So I like the idea of using one of these. I think it makes sense. Um, it'd be nice if it was fused. Current's got to be fine no matter what. How many do we have left? 29? One for that. 28 for that. Yep. Let's go with the higher voltage because we will need that. Ooh, what's this? Terminating cover. I might be looking at this wrong. Hold on. I think it might have a cover that just snaps onto it. It's hard to see the way it was drawn. Oh, here we go. We have a 360 view. Let's check this out. Whoops. Well, that was useless. Okay, so it does have a cover to cover it, and then this middle one is the ground. That's why that's sticking up. So you can connect it to a case easy or something. Okay, I think we use that then. We're going to have to design this part. I'm like almost 90% sure. Also, we need to figure out what the difference is between all of these. IEC, it's an appliance inlet. C14 or C18, sandwich mounting or PCB. So C14 is all three, C18 is just the two. Okay, so you definitely want C14. So where's the part number description? Did I just miss it? No, it's just got the list of stuff here. Oh, it's different panel thicknesses too. That's probably not going to matter to me, at least at the moment. Okay. So we selected the ones with covers, so then what's the difference between all of these? They're all 10 amp, 250 volt, current UL, unfiltered commercial, no fuse. Number of positions, so this one that's 2, we don't want that. So different panel thicknesses for some things. They're all the same size. Wow, there's really not a lot of difference going on here. I guess we just go with the first one. All right, what is the first one? 9211.13. Let's see here. 9211.13. Is it 9210? Did I get that wrong? No, it's 9211. I don't see that one here. I must have missed it. No, it's legitimately not on here. Okay. Interesting. All right. Whoa. Hang on just a second, y'all. Oh, I got a visitor. All right, so I have to take care of something. But in the meantime, I got a visitor. Say hi. She just found a lizard, so I need to go catch this thing. I'll be right back. Okay, I'm back. Hopefully y'all can hear me. Uh, oh, I was right, yeah. I thought I had the door shut, so I'm not sure how she got down here. But anyways, where were we? Also, if somebody could let me know if you can hear me, my software is glitched out, so audio levels are gone. Streamlabs does this thing where it just hides the audio levels at random. So it looks like all the 9.2 things are protection level 2 and all the 9.1s. Oh no, that's not. That's a bad assumption. All right. But seriously, oh, I've totally glossed over this. She found a lizard here. I think it was like this big. It was like 5 or 6 inches long. I caught it for the moment. Not sure how I'm going to get it back outside yet. Okay. Um, I know I've asked this already. Can somebody please verify though? Because I'm just like I said, my audio is a little weird. If they can hear me. All right. I really don't know. Like this isn't explained very well. Like what exactly is what, so I really don't know what to pick. I guess I'll just go with something. I guess this one. Let me make sure you can buy them individually. All right, you can. These must not be very popular because they have exactly 50 in stock of each. So I imagine that's like the reel or tray or whatever they buy it, whatever it comes in. Okay. Well, this is C14. That is the one I want, right? Yeah, C14. Okay. All right, let's go with this one then. So here in Circuit Maker, if we add a new part, there's no way this has a model already made. Yep. I guess we will make one. Create new component. I don't know if there's a. I actually don't know what the symbol looks like for this. If there is a common symbol. Hold on 2 seconds. Text somebody real quick. I haven't gotten any response to see if anyone can hear me. No one said anything, so I need to ask somebody. All right. Let's see here. Let me look up a standard symbol. All right, give me 2 seconds. Looking through the list here. Okay, the audio is working. Good to know. Thank you. Okay, I think I have something that can work here. I need a circle. Okay, and then rectangles. I think these go the other way, actually. That goes on this side. This one goes on this side. Let's move them up. There we go. And then a smaller circle. All right, colors. Oh, it's showing up all the way over here. Black border, okay. Is there a way to fill circles? I don't know if there is. All right, well, we'll just go with this then. Doesn't look like there's an option. All right, and then pins. All right, is the designator the name that we turn off? Designator, nope, I want to turn off the name. And then the big one is the neutral, right? I think. And then we probably want this to be 500. All right, we need to flip this around 180. Turn off the name. This is the line. Drop that right there. And then we have the ground. Well, that's really annoying positioning. Sure. All right, we need to turn the name off as well. Okay. Looks kind of dumb, but it works. Oh, that actually does. Okay, hold on. I can do something here. All right, there we go. And now we just need to make our footprint. Ugh. Just a sec. All right, there we go. It's an imperial. Might need to be in metric. All right, I need a drawing. Excuse me. This is gonna be fun to try and like make and put together and everything. Oh, I didn't even check if the one that I picked came with a cover. 921316. Hold on. U16. It does have a cover. Okay. All right. Move this over here. There we go. Looks like this is all in millimeters. Okay, let's try that. Okay. All right, so we need to go up 7.3 and over 7. going to put it way up there, yep. Alright, then the inside needs to be 1.6. Which means this probably needs to be bigger than that. Let's try 2. Okay. That's too small. Let's do 3. Give it like good contact point. Alright, cool. 7, 3, plated, all layers. Alright, so now we just need a couple more of these. Three, 0. This one's at 7, 7.3. Okay, now I need to figure out which one's which, because I don't remember. And it's upside down. Does anybody remember which one goes on what side? I'm totally getting this wrong. Oh, I can't even tell from this which one's the bigger one. I guess there isn't in this one. All right. Let me look this up. C14 pinout. Line neutral. So this is the line. I think that's what the L stands for. I might be having that way wrong too. This is G. That's neutral. This is gonna be hilarious if I get this wrong. I should do jumpers just in case. I need to put some wires on there or something. That may not be a half bad idea, actually. Okay. Oh, excuse me. All right, I need to figure out how to do a hole. I guess I gotta do another pad that's just not connected to anything. Let's see what my options are here. Yeah, I think I'm just gonna do one that's not connected to anything. All right, let's see. I just realized this is gonna be kind of a complex circuit, so this might take us some time to make, which is fine. All right, the hole size 6 millimeters. It's going to be pretty sizable. So let's go with 8 on these. Sure. And then minus, it's at 0 and negative 27 negative 27, half of that, which is 13.5. This is actually good placing. Wow, that was placed well too. Okay. And then I guess H1, H2 for... Hopefully a massive plated via like that will be pretty strong. I wonder if I should connect them to ground, just to be safe. That's probably a good idea, actually. Honestly, I probably want to go ahead and put like just a big like ground plane here. For like safety reasons. Nah, I'll leave it. I might add G1 and G2 to the symbol though. Can I move that out? Not really. Oh, that was the designator, that's why. There we go. Okay. And our continuation of the footprint here, now we just need to make the keep outs and all that. And figure out how far from the edge of the board it needs to be. The edge of the board needs to be 6.2. So let's draw a line. Oops. Let's do another line. I probably could have went ahead and put that on the right layer, but I didn't. All right, top overlay. All right, so this is going to be exactly 6.2. Probably wanted a little bit from the edge, so maybe 5. So -5, and then how far back does this thing go? Distance y. So looking here, this is that distance I was talking about. How far back does this go, this distance y? Does it tell us? Doesn't look like it. So that's kind of annoying. All right. Well, it can't ever be easy. It doesn't say. Cool. Am I just missing it? I wonder if the particular one I'm looking at has a model or something I can get. There is a step file. All right, I can put that in as the 3D model and maybe go from there. There we go. Generic. Let's upload. Okay. Huh, interesting. Definitely made it look smaller, didn't it? I'm no expert. But this does not look like our part. All right. Let's try that again. Okay. I wonder if I can look at the part number on the actual, like, the manufacturer's website. Because clearly that is not right. What is this place? Okay. All right, let's see here. Okay, got a different step file. Let's try this again. Oh, it's bigger. That's promising. Hey, look at that. It's all like really well rendered too and everything. I was supposed to have a cover, but okay. So now we need to figure out how to turn that thing the right way and get it moved around, and then we can use it to outline exactly where it needs to go. Thank you all for sticking with me on this. I know this kind of stuff can drag out and take forever, especially when we got to do custom parts and things. The NeoPixel board went together super fast because of how simple it was, and we didn't have to make any parts. But when you start getting into this stuff, it can take a long time. So which way we need to rotate? Around X. 90 degrees. Okay. Closer. Looks like it's set up right at the midpoint too, at the bottom of that. So I need to figure out that distance to know how high to raise it. Oh, it says right here, 15.85. Okay. So let's stand off 15.85. Okay. There we go. Now we're at the right height. Now we have to figure out how far off we are. Thanks. It's a model I downloaded. I didn't actually make this, but I appreciate the support. All right, so it looks like it's centered right on the front of that, so I can figure out how far that is. Yeah, okay, I can go. Six plus 6.2. So 12.2 should be the bottom of this thing. So if it's right here, what's the... 0, 0. So let's do on the X negative 12.2. Or no, it's on the Y, sorry. Okay, that's supposedly the perfect one. Hey, it looks like it lines up. Look at that. So the whole thing will just snap in when we get it. It might be a bit of a tight fit, but it should work. And those will solder right in place. Cool. And supposedly I got the things right too, so we'll see what happens. All right, so I think that's good. Well, no, it's not good actually, because I have to finish the footprint, because it's definitely not right. Although it seems to be close. All right. Here's how we do this. Move this in. We'll leave it a little outside. Same for this. A little outside. Move this up. Yep. To here. And that should give us our full footprint. Yep, lined up outside of that whole thing. Oh, cool. They even give us the markings on it to tell us which one's which. Ground, line, neutral. Okay. So line is on this side. And that's the one I marked. Okay, cool. So I did mark those correct. Excellent. So save this. Save it to the server. Okay. And now I should be able to place it. If I look it up in my favorites. Here it is. And there we go. Look at that. All right, all that work just to get that far. We'll just name it like J1. Yep, okay. So what's next? We need a transformer. Okay. This was the next thing that I thought was going to be kind of hard. Okay, in stock, active. So output voltage, we wanted 24, I guess that, and maybe everything above it too, all the way up to like 30. What if I take out the 24s? All right, primary, I think we're okay there. Current output. Wow, 10 amps is an option? I wonder if that's expensive. Let's just see. Oh yeah, $88. That's a serious transformer is what that is. Does that have like a built-in fan or something? Because that'd be awesome. All right, current output. We want probably. How much is this going to cost us? A lot. Let's say use this one. Which, we're being honest, looks kind of rough. If we go for 2 amps, I wonder what that can be like. Okay, that's more reasonable. What's the input? Some pretty awesome looking stuff going on here. I can totally foresee this going like horribly wrong. So our cheapest one is this one from Triad, which just has the wires coming out of it. Excuse me. All right, so what's the difference between these? They're both 28 volt, 2 amp. That makes sense. I like the wire leads thing too. But what's the difference between the two? Oh, one's dual, one's single. I guess we go with the single one. This one. Oh, you can split it. That's interesting. Okay. Well, this looks like a fun one. This is going to be a little confusing to get through, but all right. I think this is the part we use though. It'll put out 2 amps. So as long as we're not putting out I think that'll work. I think that'll be enough power. We can say like 500 milliamps on each channel. I know we were going for an amp on each, which might be possible if you keep it below like 12 volts or something, but I think this is probably the most solid option. I mean, price-wise, if we want more, we're going to have to pay a ton of money, so I think this is the right way to do it. All right, I guarantee this one is not already made. So this will be our next one to put together. Oh, wow, it's not even listed. Oh, this is in favorites. That's why. All right, there it is. I guess we gotta make a custom part for it. Do I do that next time or do I do it now? Because we are pretty close to the end. I think I'll do that next time. I think I'll save this. Let me look at my requirements here. Actually, while we have that saved, let's look at regulators. Let's go switching regulator. Just curious how hard these are to use. Like if we can find something easy to use or. What's the difference between a controller and a regulator? Okay. In stock, active. Oh wow, they have some that are already programmable. Let's see what they got. I might be able to cut out a part here. This is going to matter how easy it is to solder. So SOIC or through hole would be better, but I don't think that's going to be an option here. Yeah, it doesn't look like it. So SOIC. That'd be kind of tricky to solder too. That's a step up anyway. Yeah, that's not what I want. Step down. None remaining. Screw that. I'm just curious what like voltages they even allow. For what we need to do, this might not be feasible. Because our voltage input max is going to be have to be pretty high. Yeah, they don't even have anything listed. Oh wait, yeah they do. Oh wow, these are all pricey chips and pretty heavy duty. All right. Well, that was a fun little thought process. In stock and active needs to come back. All right. I want step down. All right, now mounting. I want a through hole part if I can. There we go. It just makes it easier if it is. Okay, and then we need to make sure our input voltage is high enough. It needs to be 30 or more, because we're doing 28, I think. All right, let's see what this gives us. Yep, everything's pretty heavy duty. Get rid of everything that I have to buy in bulk. Wow, these are some pretty heavy duty regulators. How much money am I spending on each one of these? Wow. This might be a good chance to try out some awesome stuff. Honestly, everything on this side. All right. Oops. Let's go buy this one. The cheapest one you can buy is $1. 270 non-stock. I thought I clicked in stock. Okay, actual cheapest one you can buy is one of these. I have a feeling it's going to need to burn off a lot of heat, so I think I'm going for one of these things. These are interestingly cheap. Positive voltage input minimum 8 volts. X35. Output minimum 1 volts, 35. 1.58 amps. Amps. We're gonna need a big capacitor on the other side to handle this. I just realized. All right, that's fine. Let's go with this one. See what it offers. Standard lead time, 52 weeks. Wow. Good thing they have some in stock. Jeez. Maybe just to be safe, we pick something that's not quite that long. they don't even have that listed as an option. All right. It comes in cut tape. Interesting. Higher dollar amount means better quantity. You know, honestly, not really. I mean, like, technically, yeah, it does, and it is slightly better quality. Um, but it's really kind of a diminishing returns thing. It doesn't make sense to do that unless you're doing stuff for industrial or military grade. In which case, you have to pay for parts that can survive special conditions, like super hot or super cold environments. But for hobbyist stuff, I mean, most of these companies, like ROM's pretty reputable. So even though it's a cheap part, I guarantee it works. Has an on-off control. That's useful. Ground. And I'm sure there's a way to wire it up. Yeah, this voltage divider thing right here. So we need to change that resistor. Looks like it requires some other parts though, so we do have to be wary of that. See, in order to make this work, I'm going to have to do a different regulator for each channel. So there is going to be a significant amount of parts that have to go on this thing. So hopefully somewhere it tells me what to do. Yeah. 100 microhenries. Microfarads, 4.7 microfarads. Interesting. All right. I hear a dog barking. I was wondering what that was. All right, I think I'm going to call it here tonight, but I'm going to mark this one because I'm probably going to use it. I'm also going to check real quick and see if it's an available part in Circuit Maker. Nope. Doesn't even have a picture. All right, we'll have to do that next time too. All right, well, thank you all for joining me tonight. This was fun. If you have any ideas for this project, let me know. Hit me up. Otherwise, I will see you all on Thursday. Oh, the parts that are coming in. I should get the components soon. But the circuit board probably won't come until next week. They're still in the middle of making it, and that's going to take some time, and especially to ship from China. So I will see you all later.